Okay, so in this problem, we are asked to integrate the square root of quantity x squared minus 1 over x cubed dx. So the first thing that I did was I didn't want two terms to be in one radical. So I used u substitution in order for me to attend to that need of mine or to that want of mine. So I designated u is equal to x squared minus 1 and went to look for the corresponding du and the rest. So in this case, the derivative of u is just 2x dx from x squared minus 1. And in order for me to replace the x cube here in terms of u, I used or utilized this u is equal to x squared minus 1. So I transpose 1 to the other side, and that becomes u plus 1 is equal to x squared. And what would you multiply to x squared in order for you to get x cubed? That would be x. Now in this case, you have to also show x in terms of u. And the relationship between x squared and x is that x is just the square root of x squared. So the square root of u plus 1 is just the square root of u plus 1, as shown here. So in order for you to get x cubed, multiply x squared times x, you also have to multiply u plus 1 to the square root of u plus 1. So in this case, I got u plus 1 times the square root of u plus 1. So the next thing that I'm gonna do here is for me to get the dx. So dx here is 1 over 2x du, as shown here. So x also needs to be shown in terms of u. So in this case, 1 over 2, x is equal to, as I said a while ago, the square root of u plus 1 is equal to x. So 1 over 2, replace x with u plus 1 to the power of 1/2, or the square root of u plus 1 du. Now, we put the values here in the original equation, or the original function, I mean. So in this case, we just take away the 1/2 here because it will go outside the integrand. Now, 1/2, the derivative of what is x squared minus 1 here. So in this case, it's u. So it's the square root of u over what we just derived a while ago from this here, the value of x cubed. So we just copy u plus 1 times the square root of u plus 1. And we also have dx here. So we just put this value right here in this. So it becomes 1 over u plus 1 to the power of 1/2, or the square root of u plus 1 du. So now in this case, we can simplify this. So the square root of u plus 1 times the square root of u plus 1 is equal to u plus 1. So in that case, u plus 1, there are two of them, that would be u plus 1 squared. Now, of course, just go on with the process and we get this. Now I did another substitution. Now I used the variable v. So in this case, I didn't want to have any radical, so I used, that's the purpose of the substitution right here. So v is equal to the square root of u, or u to the power of 1/2, and the derivative of that is that bring down 1/2, 1/2 times u, then minus 1 here, negative 1/2 du. Or it can also go by this form right here. So du can be obtained by multiplying 2u to the power of 1/2 to both sides, and you get 2u to the power of 1/2 dv. Now we remember that u to the power of 1/2 is v. So now we can express u in terms of v, and that's our goal here. So in order for us also to put u plus 1 here in terms of v, we also have to utilize this that we got a while ago. So u plus 1, that's what we need to get. So u to the power of 1/2 squared would give us u. And also we need to square the v here, and we get v squared. Now it's not done yet because we need to have u plus 1. Now u can be added by 1, and of course if you add something to one side of the equation, then you also have to add that same number to the other side of the equation. Now, u plus 1 here would be replaced by v squared plus 1. And it goes by this form right here. So, in this case, we have this already. Now, the 2 here would just go out and cancel the 1/2 right here. 2 times 1/2 is 1. And v times v would be v squared, and it's over v squared plus 1 squared dv. Now, for me to actually address this function, in order for me to solve this function, I used the plus minus method. So what I did is I added 1, and of course, in order for it to have the same value, I just subtracted 1 afterwards. And that would give me v squared plus 1 minus 1 dv, instead of having just v squared. Now we can separate these two because it's either in an addition or in a subtraction operation. So I just cut this in half, and then v squared plus 1 over v squared plus 1 squared dv, and the negative 1 here will have the same denominator. So in this case, 1 over v squared plus 1 dv is an inverse trigonometric function. It's arctan v. And that concludes this part of the function, but we need to solve this still. So in this case, I used trigonometric substitution. So v squared would be equated to x squared, and 1 here is would be equated to a squared. And we get v is equal to a tan theta, or v is equal to tan theta simply. So now we have to rewrite the equation, or rewrite the function in terms of theta. So in this case, we replace v squared rather with tan squared. As we have derived here, we just squared v and squared tan theta here. So we can get 1 plus tan squared theta squared, and of course the dv of tan, just the derivative of tan, which is sec squared theta d theta. And then we can have 1 plus tan squared theta squared times sec squared theta d theta right here. Now, this has an identity. 1 plus tan squared theta is also equal to sec squared theta. Now, we just have to square this, and we get sec to the 4th theta. And of course, we can just cancel it out with the sec squared theta up above. So we just minus the exponents, which is 4 and 2. And then if we subtract the exponents, then we get 2 in the denominator. So that would give us this, 1 over sec squared theta d theta. Now we know that this is also an identity. 1 over sec is cos. So this would give us cos squared theta d theta. This also has another form, which is 1/2 times 1 plus cos 2 theta d theta. Because we cannot really do anything about this anymore unless we transform it to another form, or we metamorphose it. So in this case, we just take away the 1/2. It goes outside the integral sign, and this will be integrated separately. So the integration of, we just have to multiply these first. We distribute the d theta right here, and we get this. Now, this part right here, I use substitution in order for me to have it easier, or for me to actually prove that the next part, or the next answer that I get would be the right answer for my integration of this. So 1 times d theta cos 2 theta d theta, and then I use u substitution, and then when I derive this, when I integrate this, d theta integrates to theta, and cos 2 theta integrates to 1/2 sine 2 theta. So in this case, we just distribute the 1/2 outside that we got a while ago, and we can get 1/2 theta 1/4 what plus 1/4 sine 2 theta. Now, we remember that we used tan a while ago. So, in that case, that's opposite over adjacent. So, the values that we got a while ago will be substituted in this, or will be reflected in this triangle right here. So, in this case, the opposite is v, the adjacent is 1, and the hypotenuse would be the square root of the square of the sums of this, which is v squared plus 1. Now, when I got a while ago the value of theta. So in this case, as I said, I got tan theta is equal to v over 1. So in order for me to only get theta right here, in order for me to cancel the tan right here, I would have to multiply it by arctan, both sides. So multiplying arctan to both sides, we get arctan v is equal to theta. So theta right here is equal to arctan v. Now sine 2 theta, we cannot really do anything about that unless we transform it to another form in order for us to actually utilize the triangle that we just made. So sine 2 theta is equal to 2 sine theta cos theta. And now this 2 here would be multiplied to 1/4 right here, and we get only 1/2. Now sine theta is opposite over hypotenuse, so that's v over v squared plus 1 as shown right here. And of course cosine theta is equal to adjacent over hypotenuse right here, so it's shown in this right here. So if we simplify this, we get 1/2 arctan v plus v over 2 times v squared plus 1 plus c. Now we have to plug in this to what we got earlier. So we only got arctan v, and we integrated this separately, so we need to put it back here. So arctan v minus this, what we just got. So arctan v minus this right here would give us 1/2 arctan v. You can just read it as follows. And of course the v here would have to be replaced by its original variable, which was x a while ago. So v would be transformed to the value of u, written in terms of u rather, and the u would have to be written in terms of x right here. So the final answer would be 1/2 arctan square root of x squared minus 1 minus the square root of x squared minus 1 over 2x squared plus c. Or we can just take off or take out the 1/2 right here in order for it to be like fully simplified, and we get this answer. It's the same.